So the next question is, if a point lies at a distance x from the dipole, the electric potential at this point is proportional to. So this is the question. So in this, we are having a new word, it is potential. So what is potential? What is potential? Difference. Then what is volt? So what is potential? Amount of work done. Amount of work done in moving. In moving a unit positive charge from infinity to 1 point against electric force. The amount of work done in moving a unit positive charge from infinity to 1 point against the electric force is defined as potential or electric potential. The amount of work done in moving a unit positive charge from 1 point to another point against the electric force is defined as potential difference. Next, the unit of potential and the unit of potential difference is volt. Okay, so define volt. The 1 joule of work is done in moving 1 coulomb of charge from infinity to 1 point against the electric force is defined as 1 volt. Here they are saying from infinity to 1 point. So we don't know from where it moves. So it is scalar quantity. Here we can say 1 point to another point, here to here, so that it will be a vector quantity. Vector quantity. Okay. So as we already studied, let us consider a positive charge. Around that, it produces the electric field. The space around the charge where its influence is felt is known as electric field. Now I am moving a unit positive charge from infinity to 1 point. So that work done is saved as potential. Okay. So potential due to point charge. Potential due to point charge. So V equal to 1 by 4 pi epsilon 0 Q by R. Q by R. Then we can say potential is directly proportional to charge. Potential is inversely proportional to distance. Inversely proportional to distance. So this is the potential due to point charge. The next one, potential due to dipole. Potential due to dipole. So V equal to 1 by 4 pi epsilon 0 P cos theta by R squared. So potential is directly proportional to dipole moment. Potential is directly proportional to, so Q into 2A. So directly proportional to charge, directly proportional to 2A, and inversely proportional to square of the distance between them. Square of the distance between them. Now we get into the question. So potential, okay. Next one, dipole. Okay, so potential dipole. Inversely proportional to square of the distance. But here the distance is taken as x. So that your answer is 1 by x squared. 1 by x squared. Okay, do you get it now? So potential due to dipole. So for that we can go for the diagram. So minus q plus q. Now it may be O to the point P where it makes an angle theta. Okay. So positive charge produces the electric field. Sorry, potential. Minus q also produces the potential. Here the remaining angle is 180 minus theta. 180 minus theta. Okay. For that, potential equal to P cos theta by 4 pi epsilon 0 into R squared. For the first case, for theta equal to 0, then cos 0 equal to 1. So 1 into something, So V equal to P by 4 pi epsilon 0 into R square. So that the OP line falls along that axis. In that axis, positive Q side. So it may be along axial line, along the plus Q side, then the potential will be maximum. Potential will be maximum. Okay, then we can go for the second case. When theta equal to 90, then cos 90 equal to 0. So 0 into something, 0. So potential becomes 0. Where it becomes 0? So minus Q plus Q. So at this point, the potential becomes 0. Okay. So on the other hand, we can discuss the same one. So when you are going in a line like this, then it is called the equatorial line. Equatorial line. So when you are going for this one, this also equatorial line. So minus Q to plus Q, the distance is 2a. The minus Q to the point is a, plus Q the point is. So at the equal distance or at the midpoint, the potential is 0, then that surface can be called a equipotential surface. Equipotential surface. So what is equipotential? The potential will be equal or it remains same. And it remains same. For which one? When it lies along the equatorial line. Okay. So now we can go to the third case. When theta equal to 180. When theta equal to 180, then cos 180 equal to minus 1. Minus 1 into something, so that V equal to minus of something. So here it will be plus, so that it is maximum. Here it will be minus, so it will be minimum. So 180. So 180 minus Q plus Q. Then O to the point P lies in the minus Q side. Minus Q side. It's also along the axial line. Okay, now do you get it now? Do you have any doubts? So once again, if your point lies at a distance x from the dipole, the electric potential at this point is proportional to. Now we are having two words, potential and dipole. Potential and dipole. Potential is inversely proportional to square of the distance. Here the distance is taken as x, so that we can write the answer as 1 by x squared. Okay, fine.